In a rare and unique experiment, shark expert Dr. Cliff and sensory biologist Dr. O'Connell will dissect this great white.
Okay, so just here behind the eyes are two pores. Let's see if we can find them. These are the external openings to the ears.
You've got to look very carefully. The openings are very, very small, so there's no external ear at all. It's just literally a pinprick opening reaching down inside.
Is just below these holes is a fluid-filled inner ear.
Nearly invisible to the naked eye, two tiny openings on the surface lead into the shark's internal ears, embedded deep within the skull. The shark's inner ear is filled with fluid, giving it direct contact to its ocean environment. While three D-shaped tubes are responsible for the shark's balance, orientation, and body positioning in the water, similar to the function in a human ear.
Now this shark's auditory system allows him to detect sounds that we can't hear, very low frequency sounds, such as those associated with the wounded fish.
So that struggling fish is just like you and I recognizing the dinner gong.
Absolutely.
A struggling seal creates an irregular pattern of splashes, and it's these sounds that attract the great white shark. The sound waves travel down into the shark's inner ear. Within this chamber, thousands of minute sensory hair cells called cilia line the walls. As the incoming sound passes over, it causes the hairs to bend. This movement triggers the release of an electrical signal directly to the brain. The great white may use its ears to listen to the seals, but it has another predatory power so advanced it can hear their movement from all around its body. The lateral line, a sense that will lead the great white directly to its prey. Buried just below the surface of the skin, a narrow tube runs either side of the shark's body. It's known as the lateral line.
There's that canal.
That's incredible.
This is the lateral line, a small, hollow tube which acts like an extension of the ear. The shark can hear all along its body. The pressure waves produced by the seal's movements pass through tiny pores on the skin surface and down into the lateral line. This main canal is lined with thousands of minute sensory hair cells, similar to those found in the shark's inner ear. These hairs are so sensitive, they can detect the slightest vibrations and turbulence in the water from hundreds of feet away. As soon as the hairs move, they stimulate nerve cells, which fire a warning signal to the brain. This early warning detection system encircles the shark's entire body, which means it can receive a constant and continuous update of the seal's location. Thanks to the inner ear and the lateral line working together, the great white can calculate the size, distance, and exact direction of the seal.